Welcome to the Quantopian lecture series. My name is Anthony Ng. I will be your lesson instructor. In 2010, I became a senior lecturer at a local institute of higher learning here in Singapore to pursue my passion, leaving behind the banking industry. I hold a double master's degree, one in MBA from University of Otago and the other Masters of Science in Financial Engineering from National University of Singapore. I help Quantopian conduct algorithmic trading workshops at the introductory as well as the advanced level as well. The lesson that I want to cover today is called Introduction to Python. This notebook is designed by Maxwell Maginot and basically is part of the Quantopian lecture series. Now, in this topic, these are the lesson outcomes or the topics that we will cover. The first one is code comments. Second one is variables, basic math, collections. These are the data types in Python, string shenanigans, how to manipulate strings, logical operators, true, false, the likes, loop structures, as well as functions. Now let's start with code comments. What is code comments? Basically, a code comments is really a note made by the programmer in the source code itself to help remind themselves. The purpose of comments is really to clarify the source codes and to make it easier for people to follow along with what is actually happening. Now, anything in a comment is generally ignored when the code is actually run, making comments useful for including explanations and reasoning as well as removing specific line of codes that you may unsure about. Comments in Python are generally created by using either the pound symbol or including a pound in a line of code, which will basically comment out anything that follows it. So here's an example. This is basically a code cell. So in this cell here, this is a running cell. This is basically a cell whereby you put comments. So in this environment called Jupyter Notebook or IPython Notebook, this portion here is called Markdown, and this portion here is called code. So you run it by pressing the play button. Okay, so you run the cell and notice that there's an asterisk there before and now it turns into 1. Nothing was run, okay, because really it's just a comment. This line of codes will not change in the values. Anything following the first hash is not run as code at all. So we're moving here now, move to the next cell, is called Markdown again. So this whole cell here, basically it won't actually run either. It's just basically you use that to actually, it's a rich text allowing you to write really rich comments, formulas and the likes. So sometimes when you're actually reading other people's code, you see this triple quotation mark or also called multi-line comments. This is not entirely accurate. This is a special type of string. Data type we will cover called a docstring, used to explain the actual purpose of a function. So here, if I run this, it's called a special string. So make sure you read the comments within each code cell. If they are there, it will provide a much more real-time explanation of what's going on as you look at each line of code. So this is just a real brief introduction on code comments. Let's move on to variables. Now, variables provide names for values in programming. It's a way for you to store a value. If you want to save a value for later or repeated use, you give the value a name. Storing the contents in a variable. Okay, variables in programming work in a fundamentally similar way to variables in algebra. But in Python, they can take on various different type of data types, meaning they don't necessarily just need to be number. It can be strings and many other things as well. So the basic variable types that we will cover in these sections are integers, floating point numbers, booleans, and also strings. Integers is 1, 2, 3, 4, so there's no decimal. Floating points basically is 1 point. There could be lots of 0. It's basically a real number as such. Booleans is either true or false or 1 or 0, and strings is, as you know, strings. An integer in programming is the same as in mathematics, a round number with no values after decimal points. We will use the built-in print function here to display the values of our variables as well as their types. Right, in this cell, I'm going to just run it so that you can see the actual output. The first one is that we store the value 50 into this variable named myInteger. The next line of code, we're going to print myInteger, comma, and also the type, okay, the data type of the actual variable itself. So when you print it, okay, it first of all print the value of the variable, which is myInteger, and also the type that, and it tells you here the type is actually an int, which is short for integer. So if we move on, variables, regardless of type, are assigned by using a single equal sign. Variables are case sensitive, so any change in variation in the capital of a variable name will reference or refer to a different variable entirely. So here we have 1, the value of 1 or integer 1, okay, is stored in the variable called 1, O-N-E. So when you print the capital letter O-N-E, now remember Python is cap sensitive or case sensitive. So if I print this, what do you think will happen? Think for a second, nothing. It will give you error because we didn't store any value into capital 0 and E. So let's just run this. Hopefully it runs as I expected it, and sure enough, yes, 1 is not defined. It gives you an error because we did not store the value into capital 0 and E, but we store it in 1. So just to prove the point, so if I print 1, you should actually get the value 1. Okay, good. So let's scroll down a little bit. A floating point number, or a float, is a fancy name for a real number. Again, as in mathematics. To define a float, we need to either include a decimal point or specify that the value is a float. And here are different ways to do it. The first one is we have a decimal point 1.0 and store it into this variable called myFloat. And then we print it, what's the value in the variable called myFloat, and also print the type as well. The second way of storing the value is we specify using a built-in function called float and bracket and put our value in the middle of it and store this again into myFloat. Now notice that this will override this previous value, but that's okay because we already printed out. Okay, so when we print it again, it will most likely, in fact, it will actually print this exact same thing. So let's just print it out, and yes, sure enough, it's exactly the same thing. So why are there two lines? This is the first line where we ask Python to print what is the value in the variable myFloat, okay, as well as the type. The type here happens to be float because we specify 1.0. It's a bit different from before. It's an int, which is short for integer. Here we print again, okay, the variable. What is the actual value of the variable? It gives us 1.0. Sure enough, because we store float bracket 1. Which specify or clearly or specifically that this is to be a float, okay, and the type is a float as we have specified here. So a variable of type float will not round the number that you stored, while a variable of type integer will. This makes floats more suitable for mathematical calculations where you want more than just integer. Note that as we use the float function to force a number to be considered a float, we can use the int bracket function to force a number to be considered an int. So here, my int is equal to integer 3.14159. That's pi, just in case you don't know. Here we store the value int bracket 3.14159 into this integer, this variable name called my_int. And when you print it, and what you get is my int. It should really be 3 because the int function, bracket function, basically only take the integer value and drop the rest. Okay, and the type should be int. Let's have a look. And sure enough, it's a 3 and the type is an integer. So int function also truncates any digits that a number may have after the decimal point. So remember this, it truncates, okay, all the value that's in the decimal point. A string allows you to include text as a variable to operate on. They are defined using either single quotes or double quotes. But you do need to be consistent. Okay, here you have 2 single quotes, here you have 2 double quotes. Right. Okay, so just look at an example on my string. This is a variable name. This is a string with single quotes and print it. And my string, this is a string with double quotes, and they should really be exactly the same when I run it. Okay, here you go, with the exception of single and double. So both are allowed so that we can include apostrophes or quotation marks in strings if we so choose. Here, let's just Jabberwocky by Lewis Carroll. Here you have double quote inside with the single quote outside. So when you print it, it will include the double quote. Occasionally you want single quote, so you have a double quote on the outside. Okay, so when we print this, there we go, double quote, Jabberwocky by Lewis Carroll, and single quote, "'Twas brilliant." Oh, I don't know how to read this. I'm just gonna leave it to you to read that one. Booleans or bools are binary variable types. A bool can only take on one or two values, these being true or false. There's much more to this idea of true values when it comes to programming, which we will cover later in the logical operations of this notebook. Here, my underscore bool is equal to true. So when you print it, it will show you this is a boolean and the value should be true. And here you go. There are many more data types that you can assign as variable in Python, but these are the basic ones. We will cover a few more later as we move through this tutorial. So let's move on to the next section called Basic Math. Python has a number of built-in math functions. This can be extended even further by importing the math package or by including any number of other calculation-based packages. All of the basic arithmetic operations are supported: the plus, the minus, the divide, and multiplication. You can create exponents by using two asterisks, and modular arithmetic is introduced with the mod operator percentage. So here's a simple one. We're going to print addition 2 plus 2, subtraction 7 minus 4, multiplication 2 multiplied by 5, division 10 divided by 2, and exponentiation. Yeah, okay, 3 to the power of 2. So let's just run this. And here you have addition is 4. Yes, it's 4, followed by 3, followed by 2 times 5 is 10. 10 divided by 2 is 5, and 3 to the power of 2 is 9. So if you're not familiar with the mod operator, it operates like a remainder function. If we type 5 mod 4, it will return the remainder after dividing 15 by 4. Okay, so let's see this. Modulo of 3. So basically, it's 15 divided by 4. You have a remainder of 3. So basically, this is mathematical functions also work on variables. Mathematical functions also work on variables. So if you look at this, we have the first integer equal to 4, second integer equal to 5. Okay, so if we multiply the two, we should get 20. So let's just see if it's what we expected to do. And yes, thank goodness, it does work that way. But make sure that your variables are floats if you want to have decimal points in your answer. If you perform math exclusively with integers, you get an integer. Include any float in the calculation will make the result a float. So basically, if you're combining an integer with a float, you will get float as a result. If you're just doing it integer with integer, you will only get integer value. So let's scroll up a little bit. Here, you have first integer is equal to 11, second integer equal to 3. If you divide, notice that 11 divided by 3 is you're going to have a long remainders. Basically, it will become a float. But there's a but here. The but here is that both of these are integer. Okay. Now, how Python will operate is that this will become an integer. So it will truncate the value after. Let's just run that just to show you what's the result. Notice that the decimals are truncated. Here, if you have to float, when you print it or when you divide, you get a float. And there you go. Right, Python has a few built-in math functions. The most notable of these are absolute, round, maximum, minimum, and sum. And these functions all act as you would expect given their name. So calling absolute on a number will give its absolute value. If you have a negative number, you will get a positive value. The round will round the number to a specified number of decimal point. Currently the default is 0. Calling max or minimum will, on a collection of numbers, will return either max or minimum, whichever one that you call. Calling sum on a collection of numbers will add them all up. If you're not familiar with how collection of values in Python work, don't worry, but we'll come to that. Additional math functions can also be added with the math package itself. So I'll just show you very quickly, but gently. So import math, this is how we actually bring in any other external library in Python. So you import math, all right? That means when that turns into a number, it means that the import has been successful. Otherwise, you will get an error message. The math library adds a long list of new mathematical functions to Python. Feel free to check out the documentation of the full list and details. It is quite long, but feel free to play around with it. There's one way to learn Python by getting your hands dirty. Right, so if you print math.py, because we imported math, okay, and also math.euler's constants, so let's just run these. You get pi, and also you get Euler's constants as well as some other commonly used math functions such as cosine. If you run that, and there you go, you get a minus because pi. Right, okay, let's move on to collections. Right, we'll start with list. A list in Python really is an ordered collection of objects that can contain any data type. We define a list using bracket, all right? Not the this bracket, but the square bracket. So here in our list, we have 3 items or 3 objects, 1, 2, and 3. So when I print it, I have 3 objects. We can access and also index the list by using brackets as well. In order to select an individual element, simply type the list name followed by the index of the item you are looking for in the braces. So here, my list, which is this one here, and bracket 0. Now, Python start counting from 0. So the 0 really is actually 1. So 0 here actually, my list 0 refers to this item, number 1. 2 here really refers to item number 3. So let's print it and see whether it works out as we say it would, and sure enough, it does. So indexing in Python starts from 0. If you have a list of length n, the first element of the list is at index 0, the second element is at index 1, and so on and so forth. The final element of the list will be at index n-1. Be careful, try to access a non-existing index will actually cause an error. So here, if we print the first, second, and third list element, okay, we'll do it this way, and print accessing outside the list bounds will cause an error. So let's see if it runs both at the same time. Quite likely we'll print the first one and give you an error for the second one. Okay, sure, it does do that. Okay, it prints the first, second, and third list elements, these 3, and then once it actually go to run the second line, it will give an error. Okay, the list is not that long. Hello. Okay, so yeah, so we can see that the number of elements in the list by calling the length. Okay, so that's how you actually check it out, just looking at the actual length itself. Okay, so len bracket function. So if you print my list, so let's come back to my list. Okay, remember my list contains 1, 2, and 3. Okay, so if you actually run this, print it to the screen, what do you get? You get 3 because we have 3 items in the list itself. We can update and change a list by accessing an index and assign a new value into it. So let's print my list again, and here I want to store 42 into the my list, and then print the list, and should change now. No longer would it be 1, 2, 3. It's most likely going to become 42 and then 2 and 3. Let's run and see. Okay, there we go. It prints the original list, which is 1, 2, 3. And now when it print the same list again, because we already assigned 42 to the first item, it becomes 42, 2, and 3. So this is fundamentally different from how strings are handled. A list is mutable. Mutable here is really a fancy word, means you can change it. meaning that you can change the list elements without changing the list itself. Some data types, like strings, are immutable, meaning you cannot change them at all. Once a string or other immutable data type has been created, it cannot be directly modified without creating an entirely new object. Right, we are looking at my string now, or string as a data type. So strings never change, so we store that into this variable called my string. So if I force, okay, the first character of my whole string to Z or Z, you will get an error. So let's run this. There we go. It does not like it. Okay, and it gives you this type error. String object does not support item assignment. As you can see, the error message is not very informative. So the best way is, once you encounter this a few times, remember them. Next time when it pops up, especially when you're writing long codes, and when this pops up, then you will remember this has to do with the fact that you're trying to change the individual value of a string itself. As we stated before, a list can contain any data types. Thus, list can also contain strings. Okay, so my list too contains strings. So if I print that, and this is what you get. And list can also contain multiple different data types at once. That's really why list is so popular and so powerful. Okay, and it stored this, but we didn't print it out. So how do we print it out? Let me just add a new line. We always want to check my list 3. Okay, and run that, and it will give you truth, and 42. Oh, sorry, truth, false, and 42. Now, the truth here is a boolean. False here is actually string. Don't be fooled, because it does actually have those single quotation mark. And finally, 42 is an integer. So if you want to put these two lists together, which two? My list 2, my list 3, they can be combined with the plus symbol. My list 4 is my list plus this plus this. When I print it, it should be one long list. Okay, that makes list very, very powerful, extremely flexible for you to play with. In addition to accessing the individual elements of a list, we can access groups of elements through slicing. So here, let me just push this up so that you can see the whole thing. Here we store this 1, 2, 3, 4, 5, 6, 7. We're storing this 7 so-called strings into this list called my list. If I run that, okay, it's stored in there. You won't be able to see anything because we didn't print it onto the console itself. Slicings. We use the colon to slice list. So here we want to print 2 to 4. Basically, this is saying starts from number 3. Okay. So in this case, countryman until land. Okay, so let me just print this so they can understand what I'm talking about. So remember, Python start counting from 0. 0, 1, 2. So it starts from 2, 3, and it stopped. Okay, or this 4 basically saying stop before 4. Starts at 2, stop before 4. Okay, it used to confuse me, but it's okay now. So once you get the hang of it, you know how it works. It's not too bad. Using colon, we can select a group of elements in the list, starting from the first element indicated and the growing up, but not including the last element indicated, which is what I just illustrated. We can also select everything after a certain point. Here we select from 1 onwards, which is item number 2 or list number 2. From Romans onwards, if we run that, here we go. We have everything. And everything before a certain point by putting colon before 4. So if we run that, so it's basically 0, 1, 2, 3. Okay, it doesn't include 4. Using negative numbers, we'll count from the end of the indices instead from the beginnings. For example, an index of -1 indicates the last element of the list. Here, if I run this, it should give me years. You can also add a third component to slicing. Instead of simply indicating the first and final part of slice, you can specify the step size that you want to take. So instead of taking every single element, you can take every other element. How do you do that? So you start from 0 all the way to 7, excluding 7, of course, and stepping 2, okay, at a step of 2. And we have, starting from 0, skip this, to countrymen, skip this, and then me, skip this, and then years. Here we have selected the entire list because 0 to 7 will use, Here we have selected the entire list. 0 to 7 will yield elements 0 through to 6. And we have selected a step size of 2, so this will spit out element 0, 2, 4, and so on through the list element selected. We can skip indicate at the beginning and the end of our slice, only indicating the steps if we like. Here, we don't specify the beginning to the end, we just specify the actual step itself. And lists also implicitly select the beginning and the end of the list when not otherwise specified. If you just put a column like that, that means everything is selected. With a negative step, we can even reverse the list. So nothing specified in the beginning, nothing specified at the end. We just put a -1, and if you run this, it go backwards. All right. Python does not have a native matrices, but with list we can produce a working facsimile. Other packages such as NumPy add matrices as a separate data type, but in base Python the best way to create a matrix is to use a list of a list. Okay, so in the future we'll talk about NumPy a little bit more, but in this we just want to give you a gentle introduction to Python. So we can use a built-in functions to generate a list. So let me just push this up. In particular, we will look at range bracket because we will be using it later. Range can take several different inputs and will return a list. So here we have b equal to 10. My list is equal to range bracket b and print my list. So basically range just count from 0 onwards. Okay, let's run this. The range provides 0, 1, 2, 3. It generates a list. In that sense, it counts. Sorry if that confused you. So if you print that, similar to our list slicing methods from before, we will define both a start and an end to our range. This will return a list that includes the start and excludes the end, just like a slice. So moving on to this cell, A is equal to 0, B is equal to 10. My list, we're specifying a range now, start from 0 all the way to 10, excluding 10 of course, and then print it out. We can also specify a step size. This again has the same behavior as a slice. So just run this, and here you go. It's skipping 2. Why don't we just change this? The beauty of Python is that you can play around with this, you won't break it. And when you do this, you get a much better intuition. All right, so notice the step size is 3 now. So play around with it. That's really what I find for me works, is just play around until I get the hang of it. So let's move on to the next data types called tuples. A tuple is a data type similar to a list in that it can hold different kinds of data types. The key difference here is that a tuple is immutable. Remember what immutable is? Immutable means you cannot change it. We define a tuple by separating the elements we want to include by commas. It is convenient to surround a tuple with parentheses. Okay, my tuple, is this. So let's just run it. Okay, see the bracket? All right, and let's run this again and notice that they are exactly the same. So it's common to actually have a tuples with a bracket. Okay, as mentioned before, tuples are immutable. You can't change any part of it without defining a new tuple. Before I run this, notice that there's actually a comment here. What does the comment say? Comment says, attempts to change the cat's value stored in the tuple to dogs. Okay, so we're trying to change number 3, which is 0, 1, 2, 3. And if you run that, you're gonna get an error message. Tuple object does not support item assignment. Okay, so you can't save, you can't change it. You can slice tuples the same way that you slice list, like this. So, start from 1, stop before 3. Okay, start from 1, have 30. And concatenate them the way that you would with strings. Concatenate really is a fancy word of saying combine. Okay, just combine them. My other tuples make that 50, print my tuple plus my other tuple, again using a plus, do just combine them, concatenate. We can pack values together, creating a tuple as above, or we can unpack values from a tuple, taking them out by doing this string 1, string 2, string b with this comma. Okay, it will unpack them. So let's just print it out. Okay, let me scroll that up so that you can see the whole thing. Okay, so my other tuple. Okay, let's see if I can see my other tuple here. Okay, my other tuple. Okay, sorry about that. My other tuple is this one. Okay, you have these three matching 3. Okay, so it actually spits it out, make that 50. Okay, when you print it, it splits and store them into those individually. So unpacking assigns each value of the tuple in order to each variable on the left hand side of the equal signs. Some functions, including user-defined functions, may return tuples, so we can use this to directly unpack them and access the values that we want. Right, let's move on to sets. What is a set? A set is really a collection of unordered, unique elements. It works almost exactly as you would expect a normal set of things in mathematics to work, and is defined as using braces. Okay, things I like. Okay, so you have a whole bunch of numbers here, just one long list. Okay, when I print it and also print the variable in here and print the type, let's see what it looks like. It's a set. Okay, so wait a second, it's a set, and wait a second, the value here is not the same as the value here. Why is that? You have a 4, you only have one 4, although you have 3 4s here. Okay, notice that what set does, set actually make it unique. All right, only it removes the duplicate altogether, and what you get is just the unique numbers. So note how any extra instances of the same items are removed in the final set. We can also create a set from a list using set bracket function. So you have a list, right, and you have a set, store it into animal set. When you print it, it will remove all of the repeats. So we have dogs, 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 sponges, sponges, gone. Okay, we only have 1 dogs, 1 sponges. Okay, calling len on a set would tell you how many elements are in it. Run that, you have 6. Right, because the set is unordered, we can't access individual elements using an index. We can, however, easily check for membership to see if something is contained in a set, and take the unions and intersects of sets by using the built-in set function. So let's do this. Here we are checking whether cats is in the animal set. So if we run that, true, meaning it's in there. So cats, cats. And here we check to see whether the string cats will contain in our animal set, and it returned true, telling us that it is indeed in our set itself. We can connect sets by using typical mathematical set operators, namely union and also and for intersections. Using union or intersection will return exactly what you would expect if you're familiar with sets in mathematics. So here you have animal sets. This is a union. In programming lingo, this is called OR. Okay, OR, OR. Okay, so things I like. So you have things I like, which is these. Animal set, which is these. And when you have an OR, basically you are combining the two. Okay, so you have a union of both. So pairing two sets together with OR combines the set, removing any repetitions to make every set element unique. So if we use an AND, basically we are asking for the intercepts. Only lizards and dogs are in both sets. Pairing two sets together with AND will calculate the intersection of both sets, returning a set that only contains what they have in common. If you're interested to learning more about the built-in functions or set, feel free to check out the documentation of Python. It's pretty comprehensive and pretty useful. Okay, so let's just move on to dictionaries. Another essential data structure in Python is the dictionary. Dictionary are defined with a combination of curly braces and also colons. The braces define the beginning and the end of the dictionary, and the colons indicate key value pairs. A dictionary is essentially a set of key values pair. The key of any item or any entry must be an immutable data type. This makes both strings and tuple candidates. Keys can be both added and deleted. In the following example, we have a dictionary composed of key value pairs where the key is a genre of fiction and the value is a list of books, which is a list with that genre. Since the collection is still considered a single entity, we can use one to collect multiple variables or values into one key pair. That's a long paragraph of words. So what does it mean? We look at this, my dic, okay? My dictionary, really. So here you have, this is the key and this is the variables. Every time you see a key is before the colon, okay? And then followed by the list variables. You have the key followed by the dictionary. Okay, sorry, the list, I should say. So let's run this. Let's store everything into my dictionary. After defining a dictionary, we can access any individual values by indicating its key in braces. So here, my dictionary bracket sci-fi, and I run it. It will bring out all of these. Okay, Book of the New Sun, Necromancer, and Snow Crash. All right, so the sci-fi. We can also change the values associated with the given key. So within sci-fi, we'll put in I can't read. And now it overrides all of these, and all that we have now is just I can't read. Okay, so the next one is we want to print. We can add a new key value pairs. All right, historical fictions. Notice that there's no historical fictions. There's weird one, there's sci-fi, there's high. So Pillars of the Earth, store into my dictionary, historical fiction, and when we print it, it is now stored in there. When I print the whole dictionary, okay, here you have historical fiction, pillars, sci-fi, only with I can't read now because we've overwritten all of these. Okay, the rest remain the same. Right, let's move on to string shenanigans. Now we already know that strings are generally used for text. We can use built-in operations to combine, split, and format strings easily, really depending on our needs. Now the plus symbol indicates concatenation in string language. It will combine two strings into a long strings. So here we have the first string, this long, second string, and the third string is combining the first and second, and the fourth line here is basically telling Python to print it out. Here you go. Now strings are also indexed with much the same way as the way list does. So you have this whole long strings. Now we can print the first letter with 0, the last letter is that, -2, 0 to 5, and it just print it out and see as it printed out the way that we want it to be. So you have uppercase S, and then you have the lowercase s, lowercase u, and on it goes. So really it's actually the same way that you index list. You use 0, -1, or using column from where to where, and also inverse it as well. Built-in objects and classes often have special functions associated with them that are called methods. We access these methods by using a period, basically full stop. We will cover objects and also their associated method more in other lecture. Now using string methods, we can count instance of a character or group of characters. So now print count the letter. So these are just description. Okay, here is I want to count how many i's there are in this whole long stretch of strings. The same way is here I want to count how many li's in here. So let's just run that. And here in this one long string we have 7. Okay, here we have 3 of these li. Let's move this up. Now we can also find the first instance of character or group of characters in a string. print the first I appear at its index, we find. Okay, use the method called .find. Earlier we used method called count to count how many of these I. Here, running it tells us number 8. The 8th character is the first time that you see the letter I. As well as replacing characters in a string, we can replace them. If we run this, all right, all I's are now A's. So instead of this supercalifragi, okay, there we go. As you can tell, I don't know what the word is. Print, it is raining cats and dogs. You replace dogs with more cats. All right, so it is raining cats and more cats. There are also some methods that are unique to strings. For example, upper will change all characters to uppercase, all right, while lower will change it all to lowercase. So here, I can't hear you, we're changing it all to upper, and here we change it all to lower. I can't hear you, I say hello. Okay, the next thing we want to look at is formatting. Using the format method, we can add in variables values and generally format our string. We have 0, 1, so 0 here is Marco, 1 is Polo. So my string is equal to Marco Polo, and here you go, you have my string is Marco Polo. Now let's just change a little bit with reverse the order, and you have Polo Marco. We use braces to indicate parts of the string that will be filled in later, and we'll use the argument of the format function to provide the values to substitute. The numbers within the braces indicate the index of the value in the format arguments. Okay, best to refer to the format documentation for additional example. If you need some quick and dirty formatting, you can instead use the percentage symbol called the string formatting operator. And let's just run this. So insert values here. So the percentage is the quick and dirty method of inserting values into this here. The percentage symbol basically cues Python to create a placeholder. Whatever characters allowed the percentage in the string indicates what sort of type the value put into the placeholder will have. This character is called a conversion type. Once the string has been closed, we need another percentage that will be followed by the value to insert. In the case of one value, you can just put it there. If you are inserting more than one value, they must be enclosed in a tuple. So here we have percentage s and then percentage s. So when you run this, you get 13 cats in my apartment. Okay, in my apartment. In this example, the percentage s indicates that Python should convert the values into strings. There are multiple conversion types that you can use to get more specific with the formatting. Best to check the documentation. This is really introductory to get you started. Okay, we're going to look at logical operators. Basic logic. Logical operators deal with Boolean values, true or false, as we briefly covered before. If you recall, a bool takes on one or two values, true or false, or 1 or 0. The basic logical statements that we can make are defined using the built-in operators. These are equal sign, not equal, less than, greater than, less than or equal to, and greater than or equal to. So here, this is about checking whether 5 is equal to 5. Good, it's true. Is 5 greater than 5? False. These comparators also work in conjunction with variables. And here is really asking you, is m smaller than n? I'm sure you know the answer to that. We can string these comparators together to make more complex logical statements using the logical operators, or and also not. Let's move this up a little bit so we can see the whole thing. So you have statement 1, 10 is greater than 2. Statement 2, 4 is smaller or equal to 6. So print statement 1, true value, formatted. Okay. Again, you repeat the same, format. All right, so this is really saying insert this here, insert this here. Is this true or false? Insert this here. True or false? Insert this here. Statement 1 and 2 combine and. So let's just run this. So this one is true. This one is true. Hence, you have the value 2 here, value true here, and statement 1 and 2, because they're both true, so the and basically gives you true as well. The OR operator performs a logical OR calculation. This is an inclusive OR. So if either component paired together by OR is true, the whole statement will be true. The AND statement only outputs true if all components that are ANDed together. That's cute. Are true. Otherwise, it will output false. The NOT statement simply inverts the true value of whichever statement follows it. So a true statement will be evaluated as false, and a NOT is placed in front of it. When a NOT is placed in front of it. Similarly, a false statement will become true when a NOT is in front of it. So basically inverting it really. Say we have two logical statements or assertion, P and Q. The truth table for the basic logical operators is as follows. I think best to let you read through those. I'll pick line number 1. If both are true, not P meaning inverted, it becomes false. P and Q, because they're both true, you get true. P or Q, because they're both true, also true. False, true, okay, when not P meaning turning false to true. P and Q, because there is a false here, so automatically it inverts to false. But if it's an OR, meaning any one of these is true, it becomes true. All right, so I'll let you play around with the other two combinations. We can string multiple logical statements together using the logical operators. Print 2 is smaller than 3, true. And 3 is greater than 0, true. True and true gives you true. Or 5 is greater than 6, false. And not 4 is smaller than 2. Is 4 smaller than 2? False, but because it's a not, this is true. Because this is false, we have to AND, because we're doing an AND. Okay, when you have a true and false and you have an AND, this becomes false. If you have a true here or a false here, hopefully the answer is a true because it's an OR here. So let's just play it. True. Okay, I strongly suggest you play around with that, work through that in your mind, because I went through that pretty quickly. But it will help you immensely by referring to the table. So logical statements can be as simple or complex as we like it, depending on what we need to express. Evaluating the above logical statements step by step, we see that we're evaluating true and true, or false and not false. This becomes true or false and true, subsequently becomes true or false, ultimately being evaluated as true. Now because we are using computers, it will calculate the calculation very quick, so it's not really a problem. But if you are a human being, the moment that you see an OR here and you have two-sided statement, you see that this is true, then you forget about the rest. Remember, anything OR true gives you true. Okay, so it doesn't matter if the second part is true or false, you will still get a true as long as this is already true. But anyway, you were using computers, so it doesn't matter. So, truthiness. Data types in Python have a fun characteristics called truthiness. What this means is that most built-in types will evaluate as either true or false when a Boolean value is needed, such as with an if statement. As a general rule, containers like strings, tuples, dictionaries, lists, and sets will return true if they contain anything at all, and false if they contain nothing. Alright, if you print Boolean, nothing, what do you think you'll get? So let's just run this. Okay, so it's false, it's got nothing. So print Boolean, it's got character, so it's completely opposite of that. It should give you a true. Now again, print Boolean, notice it's empty. What do you think it should give you? False. Again, it contains value, true. And so on. For the other collections and containers, none also evaluate as false. The number 1 is equivalent to true, and the number 0 is equivalent to false as well in a Boolean context. Alright, we're gonna look at if statement now. So let's just scroll this up. We can create segments of code that only execute if a set of conditions is met. We use if statement in conjunction with logical statements in order to create branches in our code. An if block gets entered when the condition is considered to be true. If condition is evaluated as false, the if block will simply be skipped unless there is an else block to accompany it. Conditions are made using either logical operators or by using truthiness of values in Python. An if statement is defined with a colon and a block of indented cells. So here you have this comment. Okay, so this is basic format. So you have an if condition, colon. Okay, this is indented, then print true. Else, print false. Here it's true. Okay, now the next thing, I is equal to 4. Now if I is equal to 5, remember here it means that we're storing the value 4 into I, the variable I. So if it's 5, then print that has the value of 5. Now we know that I is not 5. So remember here it actually states quite clearly that if the condition is false, it will get skipped altogether. So when you run this, most likely you're not going to see anything at all. Because in this statement, I is equal to 4. Because in this statement, I is equal to 4, and the if statement is only looking for whether I is equal to 5, the print statement will never be executed. We can edit an else statement to create a contingency block of codes in case the condition in the if statement is not evaluated as true. So we have added this. Notice that this is unchanged. Now that if this is false, this will print. Okay, so that variables I is not equal to this will be printed, as will this, because I is equal to 4. We can implement other branches of the same if statement by using ELIF, really means else if. We can include as many else ifs as we like until we have exhausted all the logical branches of a condition. I is equal to 1. If it's equal to 1, print is 1. If it's equal to 2, equal to 3, on and on it goes. Alright, so good thing is 1. So here, we can come here and change it to 4. I should get, I don't care. Yeah, there you go. So let me change it back. Alright, let's scroll this up. We can also nest if statement within if statement to check for other conditions. Alright, in this case, I is equal to 10. If this, basically I modulo 2, remember 10 is divisible by 2, so you will get a no remainder, which is 0. Then this statement is true, then they will start looking at this branch here. Right, can it be divisible by 3? The answer is no, so this gets skipped. Is it divisible by 5? If it is yes, then I is divisible by 2 and 5. Wow. Right, okay, so let's print this. There we go. If we change it to 13, what does it get? There you go, you get this. So really, that's really the basic idea of playing around with these until you understand how the conditions work. Again, you can't break it, so just play around with it. That's really the best way to get the hang of this. Now remember that we can group multiple conditions together by using the logical operators. I is equal to 5, j is equal to 12. Is I less than 10? True or false? True. And j is greater than 11? True or false? True. So if they're both true, this gets printed. You can use the logical comparators to compare strings. My string is this. If my string is equal to this thing, then print for the glory of Rome. So let's just print this and see if it's for the glory of Rome. Okay, it's exactly the same. Let me just try if we add an R here. Voila, it's not. Okay, I think you will get the gist of it. Really, programming a lot of time is about playing around until you get the hang of it. And it's really, you can't break it. Okay, as with other data types, equal would check for whether the two things on either side of it have the same value. In this case, we compare whether the value of the strings are the same. using greater or smaller or any of the other comparatives is not quite so intuitive. However, if we stay if we stay from using comparatives with string in this lecture, comparators will examine the lexicographical order of the string, which might be a bit more in-depth than you might like. Some built-in functions return a Boolean value, so they can be used as conditions in an if statement. User-defined function can also be constructed so that they return a Boolean value. This will be covered later in function definition. The in keyword is generally used to check membership of a value within another value. We can check membership in the context of an if statement and use it to output a truth value. So if this in my string or E is my string, these are my favorite vowels. Okay, so A and E are definitely in my string. Here we use the in to check whether the variable my string contains any particular letters. We will later use in to iterate through list. All right, let's scroll this up. All right, we are moving into the next section called loop structure. Loop structures are one of the most important parts of programming. The for loop and the while loop provide a way to repeatedly run a block of codes repeatedly. A while loop will iterate until a certain condition has been met. If at any point after an iteration that condition is no longer satisfied, the loop terminates. A for loop will iterate over a sequence of values and terminate when the sequence has ended. You can instead include conditions within the for loop to decide whether it should terminate early or you should simply let it run its course. Right, let's just run this and see what happens. I is equal to 5, while I is greater than 0. Okay, we reduce or take 1 or minus or deduct 1 of it, and then print I am looping how many more to go. So this 0 refers to this I here. I'm looping 4 more to go all the way down to 0. With the while loop, we need to make sure that something actually changes from iteration to iteration, and otherwise you have an infinity loop, so that the loop actually terminates. In this case, we use the shorthand I minus equal 1, short for I is equal to I minus 1, so that the values of I get smaller with each iteration. Eventually, I will be reduced to 0, rendering the condition false and exiting the loop. A for loop iterates a set number of times, determine when you state the entry into the loop. In this case, we are iterating over the list, return from the range, and the for loop selects a value from the list in order and temporarily assigns the value of I to it so that operations can be performed with the value. Range is 5, remember 0, 1, 2, 3, 4, 5. Print I am looping and add 1 as we go. There you go. Notice in this for loop, we use the in keyword. Use of in keyword, this one here, in keyword, is not limited to checking for membership, as in the if statement example. You can iterate over any condition with a for loop by using the in keyword. In this next example, we will iterate over a set because we want to check for containment and add to a new set. Okay, so looking at this, my list, we have these, memo list also have this, my new list is a set. For animal in my list. Okay, so my list meaning we are actually going through animal one by one. Okay, in my list, we go 1 and 1 and 1 and 1 and 1. Okay, if animal is in memo list, okay, so if it's in this list, memo list, then add this list into my new list. Right now it's 0 or blank because we use the set to instantiate or initialize it. So if we print this, we should have cats and dogs and cows and humans. Did I say bats? Yeah, I might have missed out bats. But anyway, there are two statements that are, these are two statements that are very helpful in dealing with both for and while loop. These are break and continue. If break is encountered at any point while loop is running, the loop will immediately end. Okay, let's scroll this up. I is equal to 10, while true. If I is equal to 14, then break, meaning we'll jump out of it. Okay, so you should see that this will run and then it will break out altogether. All right, so let's start with 11 because we have 10. Start with this and add 1, print 1, or print I. Okay, so it goes all the way to 14 and then skip out because the break is executed. Likewise here, once you hit 2, it will break out. The continue statement would tell the loop to immediately end this iteration and continue on to the next iteration of the loop. And this is the continue. Let's run this. Okay, you have I equal to 0, while I is smaller than 5, add 1. Okay, so when we start running, add 1 and print I. There you go. And then you come back here, I becomes 1 plus 1, 2, and then once the next time around becomes 3, continue means you just skip this, don't print it, come back here. Alright, so we have 1, we have 2, next is 3 is that, and then we go to 4 and print 4. Okay, this loop skips printing the number 3 because of the continue statement that executes when we enter the if statement. The code never sees the command to print the number 3 because it has already moved to the next iteration. The break and continue statements are further tools to help you control the flow of your loops and, as a result, your code. Let me scroll this up. The variable that we use to iterate over a loop will retain its value when the loop exits. Similarly, any variables defined within the context of the loop will continue to exist outside it as well. So if we do this, okay, I transcend the loop, print I am eternal, so the loop string is I transcend the loop. Okay, when you print I persist, my value is this. What is this? This refers to I here is this. So 0, 1, 2, 3, 4, and the loop string is still I transcend the loop. All right, and the last one is I persist. My value is the last one, which is 4. Okay, so within the loop itself, in the for loop, we loop from 0 to 4, okay, which is what we did here. But once we leave the loop strings remain, they persist, and likewise the value I as well. We can also iterate over a dictionary, such as this one here. Let me run the store the value into my dictionary. For key in my dictionary, print the key itself. It will print all of these. Okay, what keys are these? The first name, the last name, and nemesis. Interestingly, last name, nemesis, first name. Oh, okay. It's printing it, except that it's printing it in the order, alphabetical order. Let me just add this, just so that you can see what actually happened, why they actually came out in that order. Notice the last, nemesis, and first name. How interesting. I'm not too sure if this is exactly the alphabetical order, but seems to be organized that way. So we shall leave it at that. Very interesting. Okay, so if we just iterate over a dictionary without doing anything else, we will only get the keys. We can either use the keys to get the values like so, meaning my dictionary, which is this, my dictionary. And if you extract the key by doing the key itself, which is this one here. So let me just print that out. Okay, so you get the actual inside value. Or we can use the iter items function to get both key and values at the same time. So you get the key and also the value at the same time. The iter item function creates a tuple of each key value pair, and the for loop stores unpacks that tuple into the key value on each separate execution of the loop. Very, very handy. Right, let's move on to a function. A function is a reusable block of codes that you can call separately, or repeatedly I should say, to make calculations, output data, or really do anything that you want. This is one of the key aspects of using a programming language. To add to the built-in functions in Python, you can define your own rather than wait for someone else to define it for you. So if we would take a look at this, so we have defined this function called hello world. All right, if you look at hello world, you have this docstring and you print hello world. Okay, so when you run hello world, it will print hello world. Okay, so hello world here, bracket basically means we are running this function. So here we iterate, rather we use the for loop to repeat it 5 times, and we should print hello world 5 times. Functions are defined with def, a function name, a list of parameters, and a colon. Let me repeat this. It starts with def, function name, okay, list of parameters. In this case, there's nothing in here, and a colon, which is this one here. Everything indented below the colon will be included in the definition of the function. We can have our function do anything you can do with a normal block of code. For example, our hello world function prints a string every time it is called. If we want to keep a value that a function calculates, we can define the function so that it will return the value we want. This is a very important feature of functions, as any variable defined purely within the function will not exist outside it. So if you do this, it will be stuck. Okay, when you run see the scope, nothing. Okay, so let's just run this. When you print this, you will get error. Okay, right. When you run see the scope, nothing. When you print it, you get error. Just so that you can see that they are separate. Let me delete that for a while. Run it, notice it's nothing. So if I paste it back, you get the error again. Right, the scope of a variable is the part of a block of codes where the variable is tied to the particular value. Functions in Python have an enclosed scope, making it so that variables defined within them can only be accessed directly within them. If we pass these or those values to a return statement, we can get them out of the function. This makes it so that the function call returns values so that you can store them in variables that have a greater scope. Right, in this case, specifically, including a return statement allows us to keep the string value that we define in the function. Anything you can do, I can do better. So we are returning this function. So my string is storing whatever this print out. So when I print my string, I should get anything you can do, I can do better. And there you go. Just as we get values out of a function, we also put values into a function. We do this by defining our function with parameters. All right, the parameters here is x. Okay, whatever x is being provided, we multiply it by 5 and return it. Okay, running this, n is equal to 4, print n. And we print multiply by 5, n, which is x here, 5 multiplied by 5, and return this 5 times 5 is 25. And when you print this, you should get 25. Oh, sorry, it's a 4. 5 times 4, my apologies. I think I need to go back to primary school. Okay, so in this example, we have one parameter for our function x. We can easily add more parameters, separating everything with a comma. All right, so we define calculate area. So we have length and width, okay, and return a multiplication of the two. So length is given as 5, width is 10. So area is equal to calculate area, which is this function we define here. And length is what? W is what? Print it out, and you get the area, length, and width. The next one is we define a function called calculate the volume. We need the length, width, and depth. Okay, run this function. If we want to, we can define a function so that it makes an arbitrary number of parameters. We tell Python that we want this by using an asterisk. So this is really, we have no idea how many. So this is an arbitrary. Okay. So some value is equal to 0 for I in arguments. We just add them all up. Okay, so however many that you put in here, it would just sum them all up and return it. Because here is just keep adding them together. So we print them. Okay, sorry, I mean run it. Okay, so the first one is summing 1, 2, 3, and then the rest is the same idea. The more you put, this still the same way to do it. Okay, the time to use asterisk args is as a parameters for your function is when you do not know how many values may be passed to it. As in the case of our sum function, the asterisk in this case is the syntax that tells Python that you are going to pass an arbitrary number of parameters into your function. These parameters are stored in the form of a tuple. Okay, we have this function, we have args, print the type of args as in the argument types. You test args, which is this one here, and you put all of these in. It's actually tuple. Okay, we can put as many elements into the argument tuples as we want to when we call the function. However, because args is a tuple, we cannot modify it after it has been created. The arguments, the name of the variable is purely by convention. You could just as easily name your parameters asterisk vars or things. You can treat the args tuples like you would any other tuple, easily accessible. Easily accessing args values and iterate over it as in the above sum values function. Our function can return any data type. This makes it easier, or rather easy for us to create functions that check for conditions that we might want to monitor. We define a function that returns a Boolean value, and this is a coming example. We can easily use this in conjunction with the if statement and other situations that require a Boolean. Definition has a vowel word. Now, the docstring here says check to see whether a word contains a vowel. If it doesn't contain a conventional vowel, it will check for the presence of Y or W. Does not check to see whether those are in the word or in a vowel context. So R, A, E, or U. So for vowel in the vowel list, okay, if vowel in word, remember this is just a variable, this is an unpacking of this vowel list. Okay, if this vowel A, E, I, O, U is in the word, whatever word that we enter as part of our parameters, return is true. Okay, otherwise return false. Okay, run this. We're gonna put catnapping. If has a vowel, which is this one here, my word, which is catnapping. How surprising, an English word containing a vowel, otherwise this is actually surprising. How surprising. Okay, so that means it has a vowel. Okay, of course it has a vowel. Catnapping has multiple vowels. Okay, so the next one is point marker. You have X and Y, right? Return X and Y. Okay, the above function returns an order pair of the input parameters stored as a tuple. Okay, so you have A is equal to point marker, point maker 0, 10, B is point maker 5, 3, calculate the slopes, point A to point B. Okay, so interesting. Point A to point B. Right. Good. Let's run this, see if this likes it. Oh, okay. Yeah. So anyway, this is the input parameters 1, this is the input parameters 2. Okay, so basically this is actually calculating the actual slope. Print the slope between A and B is this. So calculate slope. This is our input parameters A, B. So when you run it, the slope is -2. And that one calculates the slopes between 2 points. All right, the final one, print the slope intercept form of the line between A and B using point A is Y minus 0 is equal to 2. Okay, so this is input parameter 0, parameter 1, parameter 2, format A1, A0, and calculate the slope. Oh, wow. Interesting. So when you run that, okay, so the slope is, so basically it writes the formula out for you. With the proper syntax, you can define functions to do whatever calculations you want. This makes them an indispensable part of programming in any language, not just Python. All right, the next steps, really there's a lot of information and materials yet to cover. Make sure you play around with the cells in each notebook to accustom yourself to the syntax featured here and to figure out any limitations. If you want to dwell even deeper into the material, refer to the documentation for Python. We are in the process of developing a second part to this Python tutorial, designing to provide you with even more programming language. Keep an eye on the Quantopian lectures page and the forums just by clicking to this link. And that's all for now. Thank you for watching Quantopian lecture series Introduction to Python.